Oh my gosh, I recognize you guys. Wow, hello. Welcome back. Today we're going to do the division property of exponents. Now, we covered this earlier in the year, but you know, sometimes we forget. Now, if you think about, let's say we had something like x to the fourth over x squared. Now, if you wrote out x to the fourth, that could be x times x times x times x, right? That's x to the fourth. X squared would be x times x. Now, the cute thing is, you could cancel out an x for an x and another x for an x. And what's left is x times x, which how would you write x times x? X to the second. Oh, so the property with division is when you're dividing with the same base, you just subtract the exponents. It's pretty easy. So if you look at this first one, a, we have a to the 6th over a to the 14th. Now here's the way the book would do this one. They'd be like, a to the 6 minus 14th, and 6 minus 14 is negative 8. And then you would rewrite that with a positive exponent by dropping it under a 1, so it would be 1 over a to the 8th. And that is the correct answer, and that is the very proper way to do it. That works. Another way to do it is they're always going to end up where there were more. So if you look, we have a to the 6th up top. There's 6 a's up there. There's 14 a's in the denominator. So they end up where there are more. There are more in the denominator. And then you just subtract them. 14 minus 6 is 8. And then you just put the place filler of 1 up top. That's the way I like doing it. Now, it can get a little tricky if you look at b here. Now, are there more c's in the numerator or denominator? We have negative 1 up top. We have positive 5 in the denominator. Obviously, 5 is bigger than negative 1. So that's where they're going to end up. But we have to do 5 minus negative 1. Ooh, what happens with minus negative? That's right, plus positive. So it's really going to be 5 plus 1. So we're going to have c to the 6th in the denominator. Now we also have the d to the 3rd over d to the negative 4th. Now what's larger? Obviously, positive 3 is bigger than negative 4. So they're going to end up in the numerator. We're doing 3 minus negative 4, which is really 3 plus 4. So we'll have d to the 7th. Now you could do it the book way. You could be like, c, we have negative 1 minus 5. D, you have 3 minus negative 4. That would give you c to the negative 6th, d to the positive 7th, and then just readjust, move your negative exponents underneath. And it gets you this. It's fine. That's cool. That all works. Now let me show you even another way. And you're like, please don't show me any other ways. You're going to throw too much at me there, Mr. Plant. But looking at this one, some people find it helpful to move the negative exponents first. So the c to the negative first, you would move to the denominator as positive 1. The d to the 3rd can stay. The c to the 5th can stay. And then the d to the negative 4th could move from the denominator up to the numerator. Now if you look, we're multiplying. Whew. And when you multiply with the same base, you add the exponents. So this would give us d to the 7th in the numerator and c to the 6th in the denominator. And some people like that because then you don't have to worry about the negative exponent thing. Hey, that's an option. I kind of like that option. It's a pretty sweet option. All right, let's try some of these out. Now look at a. Now before we get it, we have b to the 4th over b to the 9th. Now which one's larger? Obviously b to the 9th is larger. So they're going to end up where there were more. There's more in the denominator. We just subtract 9 minus 4 is 5. So we have 1 over b to the 5th. Letter B. We have z to the 10th over z to the 5th. There are more up top in the numerator. So that's where they're going to end up. 10 minus 5 is 5, so it'd be z to the 5th over 1, which is just z to the 5th. Oh my! Oh! Look at this. The A's, are there more on top or bottom? More on the bottom. There's 4 on the bottom, 2 on top. 4 minus 2 is 2, so we'll have a squared in the denominator. The B's, there are also more in the denominator. So if you were doing 3 minus the invisible 1, you'd have b squared. You got to put a place filler if you're missing something in the numerator. I feel like I have to sneeze. My eyeballs are on fire. Hey, this is why I'm not here today. All right, this one, let's try moving all the negative exponent stuff first. So this m to the negative first, I'm going to move to the denominator, make it m to the positive first. N to the second, that's all good. That can stay there. The m to the third, cool, it can stay. And then we have n to the first, great. So all I did was move the one negative exponent. Now let's look at the m's. They're all in the denominator. M to the first times m to the third is m to the fourth. Now if you look at the n's, we have n squared over n. There are more up top. And if you did 2 minus 1, it's 1. Now you always have the backup option of like writing these in a stretched out version. You could write n squared as n times n, and then you could cancel out an n for an n. That'll work every time, but that is kind of a pain in the butt. If you had like x to the 507th, you don't want to write out 507 x's, you know what I mean? So that's where the property is nice for you. Let's try this one without rewriting the negative exponents. So look at the x's. You have 2 up top, 1 in the denominator. There's 1 more up in the numerator, so we'll have x to the first up top. The y's, we have negative 1 and positive 4. 4 is obviously bigger, so that's where they're going to end up. Now we're doing 4 minus negative 1, which is really 4 plus 1. So that would mean there are 5 more y's in the denominator. And then if you look at the z's, you have positive 4, you have negative 3. There's more up top. And if you're doing 4 minus negative 3, you're like, we get it, Mr. Plant. We got the plus positive. 4 plus 3 is 7. That works. X, z to the 7th over y to the 5th. You guys know that song? All right, let's see what else we got. Yes! Scientific notation. Fantastic. When you are dividing in scientific notation, same properties apply. When you divide with the same base, when they're both tens, you subtract the exponents. But there's these numbers in front that we're going to have to divide just like normal numbers anyway. So if you did 2 over 8, in your calculator, if you did 2 divided by 8, or simplified it, it's 1/4. 1/4 as the decimals is 0.25. Times 10 to the, we subtract the exponents. 3 minus 8 is negative 5. Now remember, scientific notation is the only spot where negative exponents are allowed. So that's fine. However, it's not in proper scientific notation. Remember, the number in front has to be at least 1, but less than 10. So that 0.25 should really be 2.5. Now, if you changed that, if you made an adjustment there, you have to adjust the exponent as well. Luckily, they work as opposites. So we made 0.25 larger, which means we're going to have to make the exponent smaller. Smaller than negative 5 would be negative 6. Whoo, that was fun. Look at us. Whoo! All right, on B, you just divide the numbers out in front. If you did 7.5 divided by 2.5, it's just 3. Here we got to subtract the exponents, but keep in mind we're doing 12 minus negative 4, which is really 12 plus 4, which is 16. Does that meet the requirements for scientific notation? You bet your face it does. That number in front's between 1 and 10. We're all gravy. Here we go. 4.2 divided by 12.6. I think that's 1/3, but just double checking. So 0.333333333333. Now that goes on forever, but usually with scientific notation you would cut off at the 100th spot anyway. So we'll leave it there for now. And then times 10 to the 5 minus 2 is 3. Now, that's not proper scientific notation, silly goose, because that number is not at least 1. So it should be 3.33. We had to make it larger, so we'll have to make the exponent smaller. Smaller than 3, 10 to the second. That was delightful. So much fun. Oh, wow. Let's see what else. Oh, yeah, some mixing, some matching. Okay. Let's see what we got. 2 to the 5th over 2 to the 7th. Well, I see 7's larger than 5, so it'll end in the denominator. And if I subtract them, 7 minus 5 is 2. So 1 over 2 squared, which we could do that. What's 2 squared? It's 4. All right. This one's basically the same thing except the reciprocal. So there's more 2's up top. If you subtract them, you get 2. 2 to the second is just 4. Cute. Number 7. Are there more on top or more on the bottom? There's more on the bottom, so that's where they're going to end up. If you do 15 minus 12, you get 3. All right. Number 8. Feel free to readjust it with positive exponents. This m to the negative second could go to the denominator. This m to the negative 5th could go to the numerator. Now there are more in the numerator. 5 minus 2 is 3. So m to the 3rd. All right. 9 is as tricky as they're going to get. Look at that. No, we could adjust with the s's. So 3 over 6. Okay, the s to the negative 9th could go to the denominator. The s to the negative 11th could go to the numerator. Now we have this 3 over 6 in the front. We could just simplify that like a normal fraction. 3 goes into 3 one time. 3 goes into 6 2 times. Woo! Now the s's, there's more s's in the numerator. You got 11 up there, 9 down there. So there's 2 more s's in the numerator if you subtract the exponents. So we have 1s squared, which we could just rewrite as s squared. The only thing in our denominator is the 2. Look at 10. This is so number 10. Look at those x's. X to the 13th over x to the 13th. If you subtract those, you get x to the 0, and anything to the 0 power is just 1. So we could just cancel those out completely. All we have left is y squared over y. There's more y's up top. 2 minus 1 is 1. So we have y to the 1st. That's it. All right. Let's see if we can decipher this problem. Get it? All right. C's, top or bottom? Bottom. There's one more in the denominator. Let's try this one without even rearranging. What's larger, negative 3 or negative 1? Ooh, negative 1 is larger. How much larger? It's 2 bigger than negative 3. So we will have d squared. See d squared in the denominator. You got to put a place filler of 1 in the numerator. But again, feel free to move all the negative exponents first, and you would still end up with that same answer. Here we go. Look at those 3's. They have the same base, so we could just subtract the exponents. There's 3 more in the denominator. Cool. The m's, I have 3 up top, 7 in the denominator. There's 4 more in the denominator. And then the t's, you got 6 up top, negative 5 on the bottom. Obviously 6 is larger, but remember we're doing 6 minus negative 5, which is really 6 plus 5. So we have t to the 11th up in the numerator. Now you could trade out that 3 to the 3rd. You could make it 27. That's 3 times 3 times 3. Or you can just, for now, leave it as 3 to the 3rd. Let me see. for time's sake, because I'm recording this during lunch, we're going to go to the next chunk of notes. Which expression is equivalent to 4 over x squared to the third? So now we have a new property. We're going power to a power. It's an easy property, but let's illustrate it for a second. If you had x squared raised to the third, if you have something cubed like this, that means times itself 3 times. So that's like x squared times x squared times x squared, which we could do that with old properties. We just add those exponents and it would give you x to the 6th. But there's an easier way. Ooh. When you go power to a power, you just multiply the exponents. 2 times 3, 6. But if you have parentheses, you got to give every single thing inside that parentheses, you have to multiply the exponent by the power here. So 4 has its own exponent. It's 4 to the first. So we're going to do 3 times 1, which is 3. The denominator, x squared, 2 times 3 is 6. So we have 4 to the third over x to the 6th. Now none of these options say that, so we need to figure out what is 4 to the third. Well, 4 squared, 4 times 4 is 16, times another 4 is 64. So we're looking for 64 over x to the 6th. There it is. All right. Simplify this expression, 3 over x squared squared. So we have to give the exponent to everything. It'll be 3 to the 2nd power and x to the 4th. And we'll just change that 3 squared to 9. 9 over x to the 4th. Make sure you adjust if there are any negative exponents or 0 exponents, and then you should be good. So here we'll give it to everything. X to the third over y to the 6th. Unbelievable. Too much fun. Time flies when you're having fun. Isn't that true for everyone? All right, and then I think this is kind of the last bit of trickery that we got. When everything is raised to a negative exponent, I think this is the easier way to do it. What you can do is you can flip it, make it the reciprocal, and then raise it to the positive 2nd power. You don't have to do it that way, but I think it's the quickest, easiest way. Now we're just giving everything that 2nd power, so it'd be 5 to the 2nd over 3 to the 2nd. 5 squared is 25, 3 squared is 9. All right, one more property here. Again, we can flip it, use the reciprocal, and now it'll be to the positive 4th. Now here's the deal. We have a negative fraction here, and it's to an even exponent. That means the negative is going to cancel out, because you'd have a negative times negative times negative times negative. It would cancel out to positive. So we can ignore the negative, and we're going to give this 4th power to everything. Y to the 4th, 2 to the 4th, and x to the 4th. The only thing I would change would be that 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. So I'm going to make that 2 to the 4th, 16. All right. So work on that joke worksheet together and see what you guys can do. I bet you'll do great. You're a smart class, smart crew.